The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
So, Austin, you were talking about pupusas last time, right?
Yes.
Have you ever had an empanada?
I have never had an empanada.
So, an empanada, it's different than a pupusa, but I think the only similarity is that it's bready, and I have empanadas. I don't know how to describe it. It's just like it's a pastry. Yeah, it's a pastry that you stuff with meat or whatever meat you want. You can even stuff other things in there, and then they're crunchy. It's like perfection in every bite. I've never had a pupusa, but it's on my list. I'm gonna try that. But the empanada. So I used to manage a school that had students from all over the world. Different heritages and nationalities, and when they got to the end of a semester, they would bring in all these home cooked things and empanadas and tamales and all kinds of other things. And one time somebody got sick and they said, "Oh, it must be the food." I go, No, not the food. I ate everything and I'm fine. It's not the food. I taste everything. But when we were at the Diamond Contractor Summit last November, it was, I forget the name of the town, Aventura, Florida.
Yes.
And there was an empanada place where you walk in and it's just nothing but empanadas. And they got beef, chicken, pork, and even they got peanut butter and jelly and Nutella and guava. Oh, talk about a thing. But then, they're crunchy on the outside, soft on the inside, no matter what you get them. I bought a box of, you get a dozen and you get 2 free. And I brought them home, carried them on the plane, brought them home. My family.
I'm shocked that it lasted that long.
Well, by the time I got it to my family, there were 9 left.
Okay, that's what I was.
Yeah, and they didn't even want them. My youngest kid had one, and my wife was like, "I don't really want." They're all stuffed with meat, but they just, I don't know. I pop over with meat stuffed inside, but they're wicked good. And there's something else. There's another thing I can't remember what it's called, but there's all kinds of these things, and every country has their own thing. So you get an empanada, it's made by somebody from Colombia. It's different than one made by somebody from Venezuela. They all got their own things, but they're all good.
Their own twist to it, yeah.
So based on your description of where you got these empanadas, it looks like the restaurant was called The Empanadas.
Yes, that's it. I couldn't remember the name of it.
Let's go, Brent.
Yeah. Okay, it was nice working with you there, Brent. Okay, so that's our mission is to find empanada place the next time we all come to Swanee.
Yes, I'm going to have to try it.
The best thing to do, if we're going to be scientific about it, is to find empanadas, find pupusas, and compare, give it,
do a blind test. You got to do a blind test. Yeah.
Yes.
Yeah.
And then we'll have to give it a rating. We'll have to let our audience know which one we like best. So, welcome everybody to the METUS Tech Show. My name is Paul Shavs. Joining me in studio here is Bryn Raptor. Bryn, say hi.
Hi there.
All right. Joining us remotely from Swanee are Scott Tallman. Scotty, say hi.
Hey, guys.
And once again, from our TSA department, Technical Service Advisor, Austin Blume, coming back for part 2. Austin, say hi.
Good morning. Hi.
All right. Now, for those folks who didn't listen to part 1, Austin, you want to just tell us a little bit about yourself, what you do, and how long you've been doing it, and so on?
So I'm a TSA control specialist. I've been here 12 and a half years, and I've done a little bit of everything in Mitsubishi, but I highly enjoy the technical support aspect of what I get to do.
Yeah. And Austin, I know you've been in a couple of different departments, but I just have a question for you. Who was the best boss you've ever worked for with Mitsubishi?
That's
Put him on a spot like that.
I'd have to say you.
Oh, okay. Oh, yeah, I forgot you did work for me. Yes. Oh, that's good. Good answer. You can come back for another show.
This podcast is about to get cut short.
Yeah. So I got to tell you guys. So for those who don't know, once in a while, we'll get together and we'll record a dozen or so podcasts in one sitting. So they're not usually timely. This is a little bit different. We recorded this podcast, the last podcast that just aired last week. We recorded a few days before that. Here we are recording part 2. Today's Friday. It was released this past Wednesday. Next Wednesday, this podcast will come out. So it's very rare that we get a timely email that we can share, and I just wanted to share one with you. So one of our biggest fans, who's got some mental issues, is Nick from the great state of Hawaii, and he sent us an email, and he sent us quite a few emails. You know, I like Nick. He's hopefully he's a good sport, because when I make fun of him, he doesn't complain or anything. But he sounds like a good technician. He always wants to learn. He listens to this podcast. So he sent us an email right after, and I'm just going to read it to you. He goes, "Hi guys, just wanted to give you some positive feedback on the most recent episode with Austin Blume. That was a really fantastic podcast with a ton of good information. I've spoken with Austin on several occasions for tech support in the past, and he is a top-notch, super intelligent guy." Pause, Austin. Right. He obviously doesn't know you. Anyway, back to the email. If there was one person at Mitsubishi other than Rick Powell, and then he's got a smiley face, that I could just sit down with over a lunch and pick their brain, it would be Austin. The part I loved most about this particular podcast was hearing confirmation of certain little things that I've always suspected but wasn't 100% sure about. Case in point would be the whole universal thermistor thing. I have actually carried that thermistor on my van for about 2 years now. Anyway, I think it's such a great idea to have the TSAs on a podcast from time to time. They truly do have a unique and useful perspective on the things that inhibits the middle ground between field technician and the training perspective. Keep up the good work, guys. I listen to every episode, some multiple times. Aloha, and Nick. I don't want to identify Nick just out of respect of his privacy, but good job. I agree with that. I wasn't able to be here. I was in Denver, and I listened to the show, and I enjoyed it very much. So, Austin, welcome back, and thanks for agreeing to come back again. And and we've had some TSAs on before. Sean Patterson was one recently. We've had a couple, but I think it's a good idea. I think what Nick suggests is a very good idea. Our purpose for doing this podcast, other than us having a lot of fun doing it and gaining weight, trying out new foods, is we want to help that technician who's in the truck, the installer, the service guy is going to go out there working on the equipment. And if we can share with them, which was what you guys did, if we can share with them some of the calls that we're getting, and the idea is how do we help them to prevent from having to make that phone call? So if we can give them some knowledge that they can then remember or go back and listen to or write down and say, hey, I heard this on the podcast, and people calling in for this, but I don't have to call in for this because I listened to these guys and I know what they were talking about. So good job, and we'll just start off with part 2. So what did we talk about last time?
Well, we covered some of the more common TSA calls, things like drain faults or charge issues. Today, we've got some that are maybe a little less common, but still prevalent, I imagine, right, Austin?
Yep, absolutely.
And we're still talking City Multi for right now, right?
Yeah.
Yeah. Yep.
Okay. All right, so what's the next one on the list?
So let's start with compressor diagnosis. Typical error code might be 4250.
So that would be the error code that typically the technician would walk up to. And that would probably be displayed across the board from local controllers inside the space to maybe a central controller, and then even on the outdoor unit display as well. So it should be everywhere, and it should be that 4-digit 4250 error code. But it also, here's another key thing for technicians, pay attention to the number behind it, because that's going to tell you what address this is actually occurring at. Because a lot of technicians see the 4250 and they assume they know what right outdoor unit it is. Sometimes they end up working on the wrong outdoor unit because they don't pay attention to the address.
Yes.
Austin, last week there was something you mentioned about knowing what unit you're working on. And it kind of reminded me of something I used to recommend to all the students when I was teaching these classes. When you have a diamond system builder, and again, I'm not going to beat that. It's a dead horse. Everybody by now knows how important a diamond system builder is. But when you make an as-built, this is how an actual true representation of what's in that system. Leave that in the mechanical room, because these faults, like you said, will show up on the outdoor unit all the remote controllers, the central controller will show up on maintenance tool. It'll give you the fault and the address. And if you have that as-built in the mechanical room, you now can go look. And if you did the as-built right, you label the office as, Office 101, Conference Room 3, along with an address. So if it says address 13, you know right where to go. Address 51, you know right where to go. So that's an important thing. It saves you a lot of time because you brought up something last week that you mentioned, sometimes we fix the wrong unit. I've done it. I've done it on rooftop units. When I fix the wrong unit, I go back down and what are you going to do? You're not going to unfix it. You just got to go fix the right one. So I just want to point that out. That and where to find the faults. It's everywhere. And if the fault reaches the outdoor unit, Austin, what does that mean for our system?
So that means that essentially anything connected to that refrigerant circuit is going to be down in the water. So nothing's going to run. The only way to reset that fault, which on a 4250, it's probably just going to fault out again. But the only way to reset it is either to turn all the indoor unit controllers to the off position for at least 60 seconds or to cycle power to the outdoor unit for at least 2 minutes.
Okay.
Either one will reset the fault. But if you really do have a bad compressor, it's just going to kick out again. But I think the biggest thing when diagnosing a compressor on any of our systems is technicians get a little, intimidated by it, just because they think, it's City Multi, unicorns run this thing. So it's not quite as difficult as you think. As a matter of fact, troubleshooting a compressor on one system is the same as all the way back to R22 units, all of our M series and P series stuff. Diagnosing is exactly the same way. So I guess I could talk about how the proper way to diagnose a system. Number one would be to find out which unit you're working on. And right off the bat, you want to probably kill the power to that condenser. If it is a twin system, make sure you know which unit you're actually working on, whether it's address 61 or 62 or whatever it may be. But definitely power down both outdoor units. Isolate the compressor by taking the wires off the compressor, and then go to ohming out the compressor. So 3-phase compressor on all of our units, even all the way down to the smallest 9,000 BTU M series unit in somebody's house, still a 3-phase compressor, even though it's a single-phase unit. So ohm value should be exactly the same, winding to winding. Obviously, we don't want anything to ground, but I'll tell you the biggest problem I see technicians when they go to diagnosing a grounded compressor is they keep their meter on continuity. You guys know why that's a problem?
Yeah. Well, go ahead. Elaborate on that, Austin.
All right. So some meters, it's already built in. So you turn it to the ohms, or how I have to describe it sometimes is the upside down horseshoe, just for technicians that aren't as familiar.
Or omega.
Yeah, omega.
Greek letter, omega, okay.
But a lot of technicians are just looking for the beep on their meter, right? So touch the leads together, it beeps, and they're checking that from a compressor winding to ground. The problem is most meters only read the resistance up to about 10 to 20 ohms on continuity. So you could have a 21 grounded ohm compressor, but your meter is going to just read OL. It's not going to beep at you. It's not going to do anything. So I always have to make sure, because we will have technicians say, yeah, I checked at the ground and it's not grounded. But then I walk them through. I even have to look up the meter sometimes just to figure out what setting to go to. And then sure enough, they've got like 83 ohms to ground, or, something that isn't going to be prevalent on a continuity check, but will be prevalent on a resistance check.
So the right setting on the appropriate meter, the correct meter too, because the kind of meter you have is, you don't want to go get a $10 big box store meter or 25. You want to get a good quality, true RMS meter.
Yeah.
Yep.
So,
go ahead.
I just had a question. When we're talking about ohming out that compressor, I have seen in the manual and have heard that temperature matters.
It does.
On that compressor, as far as when you could potentially have a positive or a false positive failure for the compressor when it's actually a good compressor.
Yes. So especially if you're megging the compressor.
Mm-hmm.
So, if you do have a mega ohm meter or a insulation tester, I guess is the proper name for it. If you do have one of those, our compressors, anything above 1 mega ohm is good. So this is where those little Subco megers that you can get from a supply house, I think on theirs, anything less than 20 is bad. So you got to be careful, if you're going to actually meg it out, have a real megger with you, because you might get a false positive when it's really a fine compressor. But you might get some compressors that might meg below 1 mega ohm, but that may be due to liquid.
Right.
So, and I'll be honest, I've seen a lot of technicians replace a compressor or almost diagnose a bad compressor just because there's liquid sitting in it, liquid migration, right? And some of the easiest ways to, even if you don't have a meter with you, some of the easiest ways to tell is if you walk up to a system, it's been down overnight on a 4250. If you put your hand on the bottom of that compressor, if it's not at least ambient or warmer than ambient and it's cold or sweaty, maybe let's get a heat gun on it before we start diagnosing bad compressors.
Yeah, Sean Gallagher, who works for us, he's on our residential sales side. He used to be a DSG, part of our Diamond service group, and when he taught classes, he would take a compressor, throw it in the freezer at the beginning of class on the first day, and at the end of the second day, he would take it out and ohm it out just to prove that. So when a system is down, the refrigerant is going to go to the coldest spot. And if that happens to be outside, if it's in the 30s, 20s, even 40s outside, that's where the liquid's going to want to sit. And that's now going to act as a conductor, and it's going to show you that it's shorted. So it's important to diagnose it properly and meg it out properly. And a lot of people, I'm hearing from a lot of technicians that don't really understand how to do that. I think we did an episode on that, on megging it out.
Yes, compressor diagnosis.
Yeah, compressor diagnosis.
We actually did a training video on it.
Yeah, is that posted? The training video, is that one of the tech links we did?
It's on the contractor portal.
Yeah. Okay. Yeah. So log in, go to MitsubishiComfort.com, go to 4Pros Professionals, and log into the LMS, the contractor portal through there, or create an account and go watch that e-learning video. But that's an important thing. But we're kind of getting sidetracked. Those are important things to bring up too.
I think the other important thing is to look at your past error codes, because if you see a whole bunch of 1600 preliminary overcharge faults and then 1500 faults, and then it repeats 1600, 1500, and then eventually you got a 4250. Is it really a bad compressor, or is it just that we filled that accumulator so full of liquid because it's an overcharge fault, right? And that error code is just saying that the discharge superheat on that compressor got less than 18 degrees. So did we just fill that accumulator full of liquid to the point where every time this compressor tries to start, and it's a low torque compressor, it tries to take a gulp of liquid and just says nope?
So Austin,
what's the best way for our listeners to get the previous error codes?
Yeah, just took the words right out of my mouth.
Okay. All right. So there are two ways to do this. The best way, obviously, is going to be with Maintenance Tool. So on Maintenance Tool, there's a tab at the top labeled Maintenance Data. And when you pull that up, it'll bring up another screen that already has the malfunction log check mark for it. And all you got to do is click on your actual outdoor address you're looking for, and then monitor it, and it'll bring up the last 10 error codes. You can also use dip switches. Sometimes dip switches are much faster because do you really want to pull out a laptop if you're diagnosing a compressor? It's probably not needed. So I would say dip switches are much faster, much easier. You've just got to have a good knowledge of where to find those in the manual. But guidance would be in any outdoor service manual. It's going to be about the last 40 pages in that outdoor service manual. You'll find the either SW1 dip switches or SW4 dip switches, depending on which generation you're looking at. And then there will be a list that tells you, error code 1, error code 2, error code 3, all the way down the list. It'll give you the last 10.
But Austin, there's one more place that we can look, right?
Yeah, the central controller is probably the most convenient spot you can get them. If you can get access to the central controller, in the malfunction log of the central controller, it'll have pretty much the last 10 error codes as well. Just knowing what your error code was prior to this error code can help you kind of gear yourself in the right direction.
And the central controller gives you a little one-sentence description of what the fault is, too. So it doesn't just give you a number you have to go look up. It's going to give you a one-sentence thing, and it kind of is going to knowing what led to it is going to help you figure out. how to fix it or how to diagnose it.
Exactly. Now, I have seen a ton of units that had no liquid on them. They were just flat on charge. And you get to this 4250 error code, and all the prior error codes were 1102 compressor discharge temperature, right? So compressor's got above 248 degrees. So the compressor overheated multiple times, and then somebody just kept resetting it. And it just eventually cooked the oil, mechanically seized the compressor, something like that.
Yeah, that's a big one to watch out for, because a high discharge temperature it's a red flag. It's a warning. Yeah. Danger, Will Robinson. Let's take a look at this. Yep. Let's not ignore it. Let's not reset it.
Absolutely.
So, Austin, real quick. So that 4250 error code, is that strictly for the compressor? I mean, should they look at the power board, making sure? Okay, so let me rephrase. So the 4250 does mean the compressor overamped, but this very well could be just an inverter board, for example. So I think knowing the detail code as well. So like Paul mentioned, the central controller will give you the list of the last error codes. But what else it'll give you is a detail code for that particular error code, if a detail code exists. So, for example, on the 4250, we could get a detail code 101, which means IPM error. IPM stands for Intelligent Power Module, or a 103, which means the DC-CT overcurrent. So it means that the CT circuit for the DC side of things saw an overcurrent. Or a 104 means a short-circuited IPM or ground fault. That one might lead you straight to just checking the compressor to ground to see if it's grounded, because that's kind of like that instantaneous shutdown, because it detects that the compressor is grounded. Which is another interesting fact on our units, is you're never going to see a trip breaker ever if you have a grounded compressor. You can have a grounded compressor all day long, and that system will sit there and protect itself before it ever actually trips a breaker or blows a board or anything like that.
Yeah. Not to digress here too much, Austin, but I might have mentioned this on a previous podcast, but my very first site visit when I came to work for Mitsubishi was exactly that. Is we had an amp meter on the L1 coming into the outdoor unit, and the unit was trying to start. And I'm just sitting out there. There was no indication that it was trying to start. But this unit had been sitting there full of liquid. We were told that it would have been powered all night, and it wasn't. It was just powered a couple hours before that. Temperature outside was in the 30s. Long story short, we look at maintenance tool. We saw that it went to start up 3 times, and it couldn't. Compressor just couldn't do that, and then it faulted out. As me sitting there was no indication of that. It was only maintenance tool told us that. And we found out that the unit was wasn't powered all night. It was overcharged by 56 pounds.
It's a little much.
Yeah, that'll get a lot of liquid on the compressor.
Yeah, and there's no compressor in the world that's going to want to start when that liquid is sitting in a bunch of liquid, when it just congeals and the oil is there congealed, and it's like, it's just sludge at that point. It's not going to start.
Yeah, I think the major difference is maybe a unitary brand would just trip a breaker instantly versus ours, which the symptoms would be slightly different. So on a 4250 fault, essentially, if you reset it, what you would notice is a sequence of operation would be the fan would try to come on first, and then within 10 or 15 seconds, that's when the compressor is supposed to try to come on. So after that 10 or 15 seconds, if that fan just shuts back down, instead of waiting, that might be a time to go, well, let's go see if we have a preliminary code, which a preliminary for a 4250 would be a 4350. And not so cool thing about preliminaries is they don't show up unless you go looking for them. So that's where the dip switches come into effect, or using maintenance tool. But even the central controller typically won't show you any preliminary code. So maintenance tool or the dip switches are probably the better route if you're, or you could just sit there and wait for 15 minutes until it errors out. But looking at the preliminary code, and then every time you ever diagnose a compressor, it's always a good idea to do an inverter test. So an inverter test is probably the simplest thing you can do. So for example, essentially all of our units, all the way up to the engine, so everything prior to the engine had 2 different ways to do an inverter test. The first way would be if it's a 208, 230 model, there's a dip switch on the board. So essentially that dip switch, if you turn it on, puts you into a no load test, which is what you're doing. And by that means
you got to disconnect the compressor. Do not keep it attached, because if you do have a grounded compressor and you got that dip switch on, you are going to blow up some boards and you are going to trip some breakers. So this dip switch is for a no load test. We want to isolate, get the compressor out of the circuit, and then reset the system, get it powered back on. And then when the fans come back on, number one, do they stay running? So that if they do, that's different than what it was doing when the compressor was attached. And number two, after they're running, this is where at least 30 seconds, maybe 45 seconds after they're running, this is where you want to start to check your balanced AC voltage coming out of the inverter board. And you could do this two different ways. It's easier to do it at the inverter board on most models. So you can go U to V, U to W, W to V, or if you're got the wires off the compressor, you could go black to white, black to red, red to white. But the key thing is we're looking for a balanced AC voltage, not a specific voltage, because that all is going to depend on the meter. So for example, I had a guy who had a Fluke, and he was getting 50 volts leg to leg to leg. He didn't like it, so he went and grabbed his field piece, and he was getting 500 volts leg to leg.
Hold on, by Fluke, you mean not something odd. You mean a Fluke meter.
Yes, yeah, absolutely.
I just want to clarify that. Yeah. It's too bad. It's too bad we don't have some type of tool or a device that would just check that for you with some, a certain light pattern or something.
Yeah, this would be a good time for that plug-in. So Mitsubishi does have an inverter checker, which is really, really nice, because you don't have to worry. Is it my meter being stupid or what? Basically, you just hook the alligator clips up to each phase of the wiring, and if the lights are all on, it's good. If some of the lights aren't on, it's an unbalanced voltage.
So now it's the board.
Yes, now it's the board.
You basically isolated the board versus the compressor.
Right, and if all the lights come on, it's the compressor.
Yep, absolutely. Now, the other thing I wanted to mention is on a 460 model, it's slightly different. There's no dip switch on the inverter board, but there is a little jumper at the very top of the board labeled CN6. So that is your no load test bypass. And essentially what that does by unplugging that is that disregards the current sensors, the ACCT sensors. So if there were something wrong with the compressor and you did keep that in the off position or dip switch in the on position, you could end up damaging boards.
Austin, I love how you have all these numbers at the top of your head. You know them all. I don't remember my wife's birthday or her anniversary. And you got all these numbers just at the top of your head.
You probably don't need to publicly broadcast that there, Paul.
Oh, she doesn't listen to this. Actually, the funny thing, again, I digress again, but I was listening to one of the episodes in the car, waiting for her. And I don't know about you guys, but when I wait for my wife, we got to go someplace together. I'm ready before her, and I'm waiting in the car. I just find it easier to wait in the car, because if I wait in the house, she'll tell me, "You pressured me, and I didn't get to get my hair." So I'll wait in the car, right? When she came in, and I was listening to one of our episodes, and it was me talking about my wife, and she gets into the car, and she said, "Hey, this guy, the same thing happened to this guy that happened to you with his wife." And I had turned it off right away, and I said,
crazy.
Anyway, I digress. All right, is that it, Austin? And we got all the points across the compressor?
4250, pretty easy checks for that. It's just isolating and separating the components out of the system and seeing what does what when, in the sequence of operation. Only minor difference is on the new engines. It's actually the SW7 dip switch bank, number one to the on position doesn't matter if it's a 208 or a 460. Yeah. That's the only major difference.
And the important thing is you got to take the compressor out of the circuit.
Definitely make sure that it's isolated out of the circuit and not part of the circuit when you're doing this inverter test.
Yeah, and that's simply taking the wires off the compressor terminals.
Absolutely, yeah.
All right, that's important. So you guys all heard it here. Don't do that. It's very bad.
Well, so the next thing we have on our list is electrical troubleshooting. So are there specific components that you want to talk about there, Austin, or?
Yeah, specifically DC voltage troubleshooting. So, most guys, they know how to ohm out a thermistor or to check for grounded wires with continuity or whatever it may be. But because a lot of guys are not used to the VRF world or, pretty much any of this stuff. We do a lot of DC stuff. So direct current, when it comes to troubleshooting, it really depends on what's going on. But like low voltage shorts or low voltage troubleshooting, it tends to throw guys off a little bit. So just understanding, understanding your meter first off, because a lot of guys don't even realize they have DC voltage on their meter. If you're not familiar with it, no worries. It's just because you've never probably actually had to use it. But on your meter, it's the straight solid line with the 3 dotted lines underneath it. That's typically your symbol for DC voltage. And no shame in never having to have used it before. But now if you do have to use it, at least you know where to find it. And then the other thing is understanding a lot of meters will read millivolts when there is no voltage. So instead of just reading 0, you might read like 200 volt millivolts, and they'll think, hey, I got 200 volts DC here, but it's really millivolts. So paying attention to your meter, what symbols are on there. Is there an M on the meter? If it's millivolts, it probably means there is no DC voltage.
Right.
Yeah, that's 1,000th of a volt. So I call those ghost readings, because I've actually had the meter leads not touching anything, just sitting there waiting to take a measurement, and you've got some type of little ghost reading there. It really depends on your meter. So good point. Good point.
And the other thing I think is really important is understanding that all we're doing on all of our system is voltage in and voltage out. All right. So if you have a decent understanding of, you don't have to know every single component on our boards, but essentially we do the same thing throughout all of our systems, whether it's a 9,000 BTU garage unit or whether it's a 30-ton city multi-system, doing a server farm somewhere. Doesn't really matter what it is, but we're doing the same thing. We're taking AC voltage into the system, whether it be single phase or 3-phase, doesn't really matter. We are converting that to a 300 volt, rough about 300 volts DC. And if you wanted to get specific, it's you take the incoming voltage, multiply it times 1.414, and that will be roughly your expected DC voltage that you can get near your diode stacks where that gets produced. And so we're taking that DC voltage and then sending it multiple different places. So one place would be straight to the inverter for the compressor or the inverter for the fan motor. So this is where the inverter board takes effect, and basically it's going to invert that, say 300 volts DC into a balanced 3-phase AC voltage to be used for the compressor or the fan motor. And by the way, every single one of our fan motors is also 3-phase AC voltage, even if it's getting DC voltage to it. It just means that the fan motors themselves have an inverter board built in.
So instead of a board, it happens inside the motor. And this is a simulated 3-phase, right? Just to not to confuse anybody, but it walks and talks and smells and sounds like 3-phase AC power, but it's really simulated, and that's all we need to know. We treat it just like 3-phase in all other ways. We treat it like 3-phase, except there's one exception. With a standard, a real 3-phase motor, we want to reverse direction. We switch any 2 leads. We are never going to switch leads with any of our 3-phase motor. U has to go to U, V has to go to V, and W has to go to W. So just to make that clear. But yeah, and by the way, this technology, you're starting to see these inverter motors in small appliances. You're starting to see them in refrigerators now.
So we have the 300 volts DC go into the inverters for the loads, but then we also send that 300 volts DC over to typically a control board. And then after that control board, it's going to step it down into usable DC voltage for other components, 12 volts DC for maybe LED lights, logic, 5 volts DC for some logic, different things.
MNet, right?
Yeah. So when we get to the MNet, this is where we're going to step it down, and we're going to have 29 volts DC on City Multi for the Mitsubishi network, which is also called MNet on our side.
It's communication.
So MNet for short. Yeah, so this is our communication. But when it comes to low voltage DC, isolation is also the key. So for example, you could have 300 volts DC going into a control board, no lights on it, right? So a lot of techs would assume, hey, I've just got a bad control board. They'd go change the control board, same thing. They get no lights on it. So anytime you see, I got voltage in, but I'm getting nothing out of it, start isolating that board. Specifically unplug everything on the board except for that input DC voltage. And when you power back on, do you get your lights back? Do you get your DC voltage back? If you did, something that was plugged into that board is probably shorted to ground or shorted between itself and just dumping that DC to nothing.
And Austin, something that you said there is very important. And you mentioned this last week, but DC voltage behaves a little bit differently than AC voltage. One thing it likes to do is it likes to arc. Right. So if you have DC go into a plug and you unplug it, you're frying something. You won't know it, but you could fry something. So make sure you never, I always tell the students, never unplug or plug anything in with the power on. Kill the power, kill the power and let the lights go off and then unplug it and then plug it, kill the power, plug it in and then power it back on. So.
And to the listeners out there, what he's saying is a very true statement, because just say I may have experience in that department. Just because I don't have patience turning it off and immediately unplugging, I shorted the board.
Wait for all the lights to go out before.
I'm pretty sure Steve Pimentel has a video of me doing a class one time where I popped a high voltage DC fuse back in place just to show the guys what it would do. And it was a real loud bang. Everybody got scared and it arced pretty bad. I mean, I knew what I was doing, but it scared everybody else. So it's pretty funny.
And that's another thing I want to say about the boards, right? And you mentioned it's power in, power out. Unless you have a replaceable fuse on a board, right? A little automotive fuse or the glass bus, bus fuses. The only thing you're going to replace on a board is going to be a fuse. We're not going to go in there and get a soldering iron and solder anything in and replace it. It's the board comes out at that point. So if a board's defective, it comes out, a new board goes in. You don't need a soldering iron and try to figure out how I'm going to do that.
Austin, by the way.
Well, I will. Yeah, go ahead.
By the way, I may or may not show that video of you making that.
Oh, you should.
Big pop.
You should.
When I do talk about the RYTPN. Plug.
Oh, yeah.
So people can test that high voltage.
It's a good one.
Inverter. And I'd say just be careful with your leads. This is the kind of stuff that can happen.
That's pretty funny.
Now, Austin, can you explain what that plug is that Brent just mentioned to our listeners?
Which plug was it again?
It's
the RYPN.
Yeah, your RYPN.
Oh, RYPN.
Yeah.
So basically, that's just your way of checking your positive and negative for DC voltage. Instead of you having to take the board. So if you're familiar with the N generation, essentially it is a lot more compact, and there's reasons for why it needed to be compact. But they did give you a very convenient way. There's a plug on the front. Steve, it's near the right there at the front, right?
Yes, it's a black plug. Right. And it's at the front. And when you look at the boards, it's going to be to the right. And you'll see a white plug with a red jumper wire, and it's going to be right next to it. You can't miss it.
Yep. Yeah. And it's a black plug. And essentially, it's just got two wires attached. And that would be the same as you going all the way back to your inverter board or power board and trying to check for DC voltage. It's your high voltage DC.
And just to be clear, that's Scott, not Steve.
I realized that after I said
Steve's on vacation. He's fishing. He's fishing every morning. He's on his bass boat and he's out there fishing every day. The guy's got the perfect vacation. By the way, Steve has the perfect vacation. His wife is working. His kids are in school, and he's going out fishing every morning.
He's enjoying every moment.
That's a real vacation. No wife, no kids. So again, my wife does not listen. And Scott, by the way, congratulations! You just got yourself a new wife.
I did. Thank you.
Yeah,
I appreciate
congratulations on that. Yep. Obviously, her family must owe you a lot of money or something. So I'm guessing.
I'm not that bad, Paul.
Yeah. Yeah. No, I haven't met her yet, but I've seen photos of her, and I'm going to tell you, you were married way above your pay grade. That's all I'm saying.
Yeah. Again, you're not the only one who told me that, so thank you. Yeah.
All right. We digress again. So next issue. Well, listen, we were talking about the DC voltage. Let's talk about the bus bar.
So the bus bar voltage drop, that is one of those brain scratchers sometimes that will throw a tech off, because sometimes it's not always clear, especially if you look in the service manual. The troubleshooting for it may tell you to change a board, but it may not be a board. So understanding the voltage in and voltage out is probably the best thing you can do for yourself. Specifically, if you look in the service manual, there are things called test point diagrams. And essentially, it is an accurate pictorial diagram of each board, and it will point out voltage on each particular plug if it's prevalent. It doesn't really tell you everything, but it will tell you the most important things. So what the voltages should be. So when it comes to a bus bar voltage drop, there are a few reasons why this can happen. But essentially what it is all of this AC voltage that goes into the system, like I said earlier, goes to a diode stack. It's going to produce that roughly 300 volts DC. And then you take that multiplier, the 1.414, and that's usually what you're going to get for your DC voltage. So a lot of our units will work off of that DC voltage. Now, during operation, sometimes that voltage has to rise. Sometimes you may not see it rise because all that's happening internal. But then again, on other units, sometimes you will see it rise. And typically it's going to rise. So like when you have compressor operation, typically it's going to rise about 50 volts. So if you normally have 310 volts DC, coming into the system, you might see 360 volts during compressor operation. And like I said, sometimes you're not going to see that voltage rise because that part of the job is being done in a certain different part of the board. It's not really checkable after that. But then again, some other units you can see that. So the whole thing with DC voltage, the bus bar voltage drop is going to be that during operation, the system does not want the DC voltage to drop below a certain number. And that number may vary depending on units. So like P-Series units, it's below 310, where I think on City Multi-side, it's below 200 volts DC. So that also could indicate a higher incoming DC voltage as well. So bus bar voltage drop is a thing. It's not a very common thing, but when you do come across this error code, it can be difficult to troubleshoot, and there are a ton of reasons for it. So just sequence of operation. Essentially, if you just take one of our K-gens, K-generation units, I think that's the easiest one to look at because it's all laid out, like from left to right as far as board structure goes. So you have AC voltage coming into the noise filter board. Out of the noise filter board, that three-phase AC voltage gets sent over to the inverter board where it's converted to DC voltage. And out of that inverter board, we're going to have that 300 volts DC. But here's the kicker is the negative is going to go everywhere the negative needs to go. But the positive has to pass through a current limiting resistor and then to a mechanical relay labeled CN72C. Now, all of our units have this mechanical relay. So on M series, it's going to be labeled the X64 relay. On P series, it's going to be labeled the CN52C relay. And then on City Multi, it's always called CN72C. And what this does is it passes the positive leg of the DC voltage through this current limiting resistor, which is going to protect against inrushing current. All of those resistors are 20 ohms. So if you're ever curious if it's good or bad, it's always going to be 20 ohms, no matter what's printed on it, because there are a lot of current limiting resistors out there that will say that it's 20K, but that's not correct. I don't know it, but that's just a printing mistake on the actual ceramic resistor, but it's all 20 ohms. So once it passes through this current limiting resistor, it goes over to this mechanical relay. And on the City Multi, it's kind of nice because you can actually take a look at the LED display, and on all of our LED displays, there are certain flags that show up depending on what the system's doing. So flag number 5 is for when that contactor is supposed to be closing. So generally on a startup, the system's going to boot up, and eventually once it's booted up, you might have a flag on flag 7 and 8 saying, hey, and I'm ready to go. But then when you actually get a demand call from the indoor units, flag 5 is going to light up, and then you distinctively should hear a mechanical relay just click. right? Right at that same time, it should click, which means that we're no longer going to be passing power through the current limiting resistor. Now we're going to be passing all the power and all the current through the mechanical relay.
Yeah. And those LED flags, just to be clear, that's the 4-digit display. If there's a fault code there, it's going to give you a 4-digit. But now when there's no fault code there, it's going to look like a series of 1s or 11s.
On the LED display, you have it's in essentially you will have a bunch of 1s, and it's in essentially a total of 8 1s, and we call them flags.
Correct.
And then, like in my class, I was like, you walk up a unit and you see a bunch of 1s, those you're flagged out, meaning you should be very happy. You have no fault codes in the system. The system should be running correctly and whatnot.
Yeah.
So
don't be looking.
And I show them.
Do not be looking for fault code 111.
Yeah, exactly. Yeah, because we all know that's happened.
The biggest place, or the easiest place to figure out what those 1s mean is actually on the schematic of the outdoor unit itself. Right to the right, I think, or to the left, but it's going to be on there. It's going to say LD1, LD2, all the way through number 8. And it's going to just say what those items mean. So like number 1 would be compressor operation. Number 5 is your 72C contactor. Number 7 means it's the OC. Number 8 is just always going to be on because it's CPU operation. Yeah.
Yep.
I like the way he rattles this off the top of his head. He's taking a call or two.
So so often number 7 is because it's twinned out, right?
Yeah. So typically, if you had a single outdoor unit, you're always going to see 7 and 8 lit because the OC, the outdoor condenser, that's the main outdoor unit. You're always going to have 7 lit. But if you ever had a sub outdoor unit, so a secondary condenser twinned with this one of those units is going to have a 7 on it lit, and the other one is not. It's just going to have one's going to have 7 and 8, and the other one's just going to have 8. So you can easily know which one's your OC or your OS, so your outdoor condenser or outdoor sub.
Cool.
Right. Rather than not looking at the address at that point. Correct.
Yeah, exactly. Yeah, if you were curious, just from a glance, you could see that.
Nice. Okay.
All right. So, Austin, let's move away from electrical and talk about something that's quite common on startups, and that's port assignment errors or porting errors. Let's talk about that.
Yes. All right. So those actually are common 20 years down the road. Really? Believe it or not. Yes. I had one yesterday. It was a 14-year-old TGMU model.
Wow.
So that's like our first generation 2006 R410A VRF systems that we had in the US. And they had a port assignment error. So essentially a port assignment error is going to be, let's just take, for example, we've got a 10-port branch controller. All right. So on that 10-port branch controller, room 1 physically is piped to port 1. Room 2's piped to port 2, room 3's piped to port 3, so on and so forth, all the way down to number 10. But during the setup process, which everybody hopefully was familiar with, and I know you guys hammer this hard in training class, but on the indoor unit, there are 3 rotary dials. SW12 is for your 10's place, SW11 is for your 1's place, so that gives you your address. And then there's a port or a branch number, which is SW14. So you've got 1 through 9, and then you go A, B, C, D, E, F. So A being 10, B being 11, F is going to be 15, 0 is going to be port 16 for the potential use of a 16-port branch box. So it's not uncommon for people to get, let's say address 1, they accidentally set it to port 2. Or vice versa. Maybe they set it correctly according to the Diamond System Builder that was given to them, but the installer's got the pipes backwards. So address 1 is supposed to be on port 1, but the installer's accidentally got it to port 2. Now, this may not be caught on startup, and the reason is because if you give a command for everything to go into the same mode, you are not going to know there's a problem. Mm-hmm. Right. So if port 1 and port 2 are both calling for cooling, both are getting refrigerant, and then the individual indoor unit's going to modulate the expansion valve, depending on the need, and then it's going to cool just fine. But what happens when the person in office 1 either turns their unit off or turns it to heat? Let's say they turn it to heat. Well, now they're sending hot gas to indoor unit 2. Indoor unit 2 is calling for cooling, so indoor unit 2 is sending cold refrigerant to indoor unit 1. So both of these people are, hey, I got mine in heat, but it's freezing in here. And the other guy's, I got mine in cooling, but it's overheating in here. So port assignments are very prevalent, believe it or not.
Yeah, and you won't notice that in, like you said, if you do a startup where you just turn everything on in the same mode, and you got, the heat of the summer or the dead of the winter, you may not notice it until the shoulder months, especially if one of those rooms is on the north side and the other room's on the south side, you're going to notice something because one's going to want heat, one's going to want cooling. So yeah, it could be a while, but you avoid this by verifying the port assignments with maintenance tool, and you watch your maintenance tool and you manually, I don't want to go through the whole process now, but you're basically manually going to open up the right solenoids for heating and cooling, one zone at a time, and you're going to make sure that zone you do it in is the one where you see the temperature changes on the indoor unit. You do this, and you're going to find all of this before you leave. So on startup, you want to verify those port assignments.
Absolutely.
And if you want to find out how to do that, attend one of our City Multi classes, and we actually go over that. Don't we, guys? We still do that, right?
Yeah.
Okay. All right.
Yeah.
Just making sure.
Another thing, you guys in the field, if you can't attend the class right away, but you think this might be a problem, head over to mylinkdrive.com, and up at the top right-hand corner, search for a PURY-P144 TKMU. And in the install section, there is a nice little layout called City Multi-Equipment Startup Process. It's a nice little PDF, and you're just going to go on down to page 9, I believe, and it's right there laid out step by step, nice screenshots. So if you're unfamiliar with how to do it, that is a quick, easy way for you guys to get to it. The only reason I mentioned that particular model number is because I know it's on there. I don't think it's on all City Multi-Outdoor units yet, because for whatever reason.
It's all on the P, all the Ps, it's on there, on the P
Is it?
models. Yeah,
Okay.
you go to the install, it's sitting right next to the install. And the good thing about that, what you just said about going to that PDF document, Austin, is I mentioned this to all my classes, to all my contractors. I say, guys, the best thing is they have pictures. People, we love
pictures.
sometimes they don't like to read, but they love pictures. So yeah,
Absolutely. Yeah, and I was wrong. It's on page 10. I just looked it up. So
Yeah, we should make an e-learning on that, a tech tip video on that. That's probably a common one to do. But then if we do that, people won't come to class. No, never mind. Just come to class. All right, Austin, I think we got time for one more topic. What do you want to end the show with?
I think the last thing would be application issues. So knowing the limitations of what the system can and can't do is really important. And a lot of this is not going to be per se on the guy trying to troubleshoot it, so the service technician. A lot of this is designed up front from whether it be the engineer or maybe a mechanical contractor that picked the equipment. But knowing what the unit can and can't do is pretty important. So example, on an R2 system, we do allow you to overconnect the indoor units by up to 150% connected capacity. All right, so that's a great thing you can do. But you got to understand that at any given point, the outdoor unit is only going to give you what it is rated for.
Right.
So
I need to keep
didn't know that.
Now, let's keep this simple, Austin. Let's use some simple math here. I have a 10-ton outdoor unit. I need a minimum of 5 tons of indoor units connected to it for it to work, or 50% of the capacity, right?
correct.
And I have a maximum of 15 tons that I can connect to it. So I can have a 10-ton outdoor with 15 tons of indoor units connected. Mm-hmm. But at any given time, that outdoor unit can only put out 10 tons. Right?
Exactly.
So the idea is that I don't need all 15 tons at the same time. Right? I can do 5 tons here and 5 tons there. And then as the sun moves from east to west, as it does here in Boston, it goes east to west. I don't know what it does in Atlanta, right? But it's sort of like, hey, the sun is on the east, that's the warmer in the morning, and on the west, it's warmer in the afternoon. So that's it. So, and that's an application thing. And if you get that wrong, if you're going, for those who design, and I don't know who's listening is going to design, but you got to make sure you do that right and speak to our engineers before you do this. Because this is one of those things that you're not going to fix overnight, and it's not. There's no service technician in the world that's going to be able to fix this issue.
This also kind of comes down to, like, if you guys are troubleshooting refrigerant or anything like that with maintenance tool, realize what you have connected to the system. So you may not want to run all the indoor units if you're trying to see if the charge is good. You probably want to just do a 1-to-1 ratio.
Yeah, good point.
Yep.
That's true.
So to my point, Austin, when I teach, I go over that in my class about what this exact scenario. And so to hit it home with them, I ask them, do you guys know VAV boxes and how they run? And majority of the class said yes. And the idea of the VAV system, right, is only roughly 75 to 80% of VAVs are operating. And then as those satisfy, the other 20% that are not operating, their dampers open, et cetera. So my background, you guys don't know, is airflow. And so that is in essence how a VAV system is, kind of like our R2 system. They overload. That's the same thing what we're doing here.
Yeah, and another application issue, Austin, is, so the R2 has the branch box, and we can have simultaneous heating and cooling. I can have one unit in heating and one unit in cooling. And if they're the same capacity, I'm just moving the heat from the one who doesn't want it to giving it to the one who does want it. But a Y series is the whole system is in heating or the whole system is in cooling. And I've seen a couple of jobs where, it's an office building. Like a Y series, you got a big open area, it's great. If every room's going to need to be in the same mode at the same time, it works great. But when you got some offices, like hotel rooms or something, and you put a Y series there, if one person's in heating, everybody's in heating. If one person's in cooling, everybody has to be in cooling. So if you think you're going to have mixed modes, you need to go with an R2 rather than the Y series. And it's really heartbreaking when you see that misapplied like that. So, and again, that's one of those things a technician can't do anything about that. So those are the things. Those are the ones that really are heartbreaking to see.
Yep. The last thing I would throw in there for anybody designing the system is if you have a server room, get a dedicated system. Don't take an indoor unit off of a R2 system with a branch box. You'll thank yourself later.
Yeah.
Yep.
Yeah,
And what outdoor unit would you go with? P series?
It depends on the load.
Okay.
Obviously, if it's a huge server, we do have low ambient kits. You can technically make it work down to a certain temperature. You probably want to talk to somebody about that, look at the submittal to see where you live and if that's even an option. But yeah, you could put 30 tons straight cool on a large server farm of some sort, or multiple of those, which we've seen them done at different server facilities.
All right, Austin, thank you so much for being on here 2 weeks in a row. And I think we're going to have you back next week to talk about some common M&P series faults. So thank you for the knowledge that you bring and the experience. It's really valuable and something that we don't usually, I'm speaking for myself, some of these things, I don't really think about these that often, and it's nice to have. So one last thing, Austin, will give you the last word on this. If a technician is having an issue, he's on the site, he's got a Mitsubishi City multi-unit or an M&P unit, where does he go for help? Or I'm sorry, where does he or she go for help? Because there's a lot more female technicians out there, which I'm happy to see.
Agreed.
So not to be sexist.
Yeah, there are a ton of them. So I think for literature, it's always going to be mylinkdrive.com.
Yeah, we don't mention that.
We don't mention it enough. A lot of techs, as good as they are, they may have never even heard of it just because it's not thrown around like it should be. But that's okay. Mylinkdrive.com. It's got every service manual, engineering manual, everything you wanted to know about the system and what it can do.
And you do not need a login.
No login.
Yeah.
And when you call tech support, that's all we're looking at. We don't have any special anything. We're just looking at the same thing that you guys have access. The only difference is we do it every day, right? Yeah. It's okay if you need to call us, but if you need literature or whatever. But I think if you need support, your local DSG member would probably be the best person I could think of to reach out to. And if you're not familiar with who the DSG is, then you can always ask somebody at your distributorship. We're always available at 1-800-433-HVAC or 4822 at the end for tech support. We're there Monday through Friday, 8 a.m. to 7 p.m.
You were going to steal my line because I was going to say that phone number rings 24/7, but we only answer it Monday through Friday, 8 to 7. So, okay.
Yep.
Austin, thanks again, and we'll see you next week.
All right.
So
have a good one.
All right. So you guys want to hear something about Austin? When we were sitting, I forget where we were, in an office somewhere, and I was reading an article about all the foods that Americans like, but Europeans find disgusting. And every time I mention the food, I go, "Oh, look at corn dog." Austin's like, "I love corn dogs." And I go, "Oh, peanut butter and jelly sandwich." Oh, and Austin's like, "I love peanut butter and jelly." So basically, every food that was on the list that supposedly Europeans find disgusting, Austin's
Because
like,
what you just described is delicious. I'll eat a corn dog, peanut butter and jelly.
Yeah.
Oh yeah.
Yeah, they put beans on toast though. So
Yeah.
Their food is too bland.
Yeah, it's cheesy. Well, it depends on where in the world you go. But yeah, and by the way, just something you mentioned off air, there, Bryn. An empanada is nothing like a hot pocket. So it's just
reminiscent.
Yeah, no, it's not. It's totally different. You can actually eat an empanada.
The only difference is it's not
to
frozen.
his defense, I mean, it's flaky pastry with stuff inside.
Yeah, remember the old McDonald's apple pies, the ones that you would like 6,000 degree filling.
Yes.
You'd burn your tongue, your lips, your chin. It'd just be back to the good old days.
We used to call those apple empanadas.
Yeah, deep fried apple pie. It doesn't get any better than that. All right, we'll talk to you later.